What is collider production for dark matter detection? Imagine trying to catch a ghost that slips through your fingers no matter how hard you try. That's kind of what scientists are doing when they use colliders to find dark matter. Colliders are giant machines that smash particles together at incredibly high speeds. The most famous one is the Large Hadron Collider, which is located underground near Geneva. It can accelerate protons to nearly the speed of light, which is about 186,000 to 180 miles per second. When these protons collide, they releases a huge amount of energy, around 13 trillion electron volts, or TeV. These high-energy crashes mimic conditions just after the Big Bang, giving scientists a chance to create particles that are normally invisible in the universe. Dark matter makes up about 60% of all the matter in the universe, but it doesn't emit, reflected, or absorb light. That means we can't see it directly with telescopes. Instead, scientists look for signs that dark matter might have been produced in these high-energy collisions. One way is by tracking the momentum of all the particles that come out of the collision. If the total momentum doesn't add up to zero, it suggests some particles escape detection. These missing particles could be dark matter particles slipping away unseen. Detectors like ATLAS and CMS are huge, complex instruments that surround the collision points. They track every particle that emerges from the smash-up. When they notice something vanishing or disappearing unexpectedly, it's a clue that dark matter might be involved. Sometimes, scientists look for unusual patterns in how particles decay, like the Higgs boson decaying into invisible particles. They also search for signs of new particles that could act as messengers, connecting dark matter to the particles we already know. This method is different from other dark matter searches. Some experiments try to detect dark matter directly underground, where it might bump into nuclei. Others look for signals from dark matter particles annihilating in space. Collider production is unique because it tries to make dark matter right here on Earth, in a controlled lab setting. It's like trying to produce a ghost in a bottle and then catching it in the act. It's a strange and fascinating process. Scientists are recreating tiny cosmic events inside enormous machines, hunting for particles that leave no direct trace. Instead, they're relying on the absence of signals or the odd behavior of particles to find clues. Despite decades of effort, no one has yet produced a confirmed dark matter particle at a collider. But every experiment narrows down what dark matter could be, turning the search into a cosmic detective story filled with strange clues and surprises.